Hello, welcome to Renesas Timing University. I'm Steven Gutierrez. In this video, we're going to be talking about general layout considerations. To explain the concept, I've drawn a simple device. Let's start talking about our clock traces. So we have our input traces. If you have a parallel termination, we need to make sure that our pull up and pull down resistors are placed as close to the device as possible. This ensures that the termination or the transmission line matches the end termination. We also have to make sure that our impedance is according to that resistor. So it could be 100 ohm differential, or depending on your application, it can be 85 ohm differential, or if it's single-ended, it can be 50 ohms or 42.5 ohms. On your output, likewise, we want to put the termination resistor at the end of the transmission line right where the receiver is. And let's say this is a differential 100 ohms, we place it right at the receiver. Now, if your signal is a single-ended output and you have series termination, you put that resistor right at the output. So that ensures that this has a matched impedance to the transmission line. Next, let's talk about the power filter. You want to have the bypass caps as close as possible to the power pin. Let's say this is on the top layer. If you don't have room to put the cap on the top layer, you can put it on the bottom layer. We use a very thick via to reduce inductance. That helps optimize the power filter. We also, on some chips, can have very sensitive regions. If you have a crystal, that input is very sensitive to noise. So have the traces be very short and symmetrical, and have this keep out region. So we want to ensure that we don't have any switching noise or any switching signals running through this region. We want to route those signals around. We also recommend having a little notch on the top layer. So create this little void on the top layer. So if there's any noise transversing the board, it doesn't couple into the crystal. Likewise, if you have a loop filter, you also want to have a keep out region to ensure that you don't have any noise coupling into there. So not only do we pay attention to our chip and our devices, but we also need to pay attention to other signals running on the board. So if you have another clock signal or another switching signal running adjacent and parallel to the clock, that's going to couple. So you want to make sure you don't do that on the same layer. Put it on a different layer. Now, if for some reason you have to cross over, instead of crossing parallel on a different layer, cross perpendicular on the other layer. So in general, these are the things we look at when we do the filtering or the layout for a device. We look at the trace impedances, the location of the terminations, the power filter, and then we pay attention to sensitive regions, and then we make sure that we don't have switching noise adjacent to our device. And let me also mention, not only can signals be noisy, but you can also have a switching power supply that can be noisy. It can couple. So pay attention to other noise sources so that we can have an optimal design. So thank you so much for watching this video. I hope it's been helpful. And check out more of our videos on Renesas Timing University.